Okay, let's try another one here. Let's backtrack a little bit. I want you to let's start with an easier one. Okay, I want you to find
Two.
Okay, how'd you get that?
Because that's the average, 0 to 4.
That's not why.
Isn't it?
You're right, but that's not why.
0 plus 4 divided by 2 is 2.
That's not why. Okay, so then if that's the case, so there's problem one. What would be the?
Isn't it because you have to take the derivative of the?
You guys, you're not even using your calculus grinders.
Because it doesn't even
It's
look like
literally-
calculus.
Oh, it's calculus.
But it,
I don't know calculus.
I'm sure there's some way to apply calculus to it.
No, it is inherently calculus.
What's the first step?
Here's why. Because, okay, let me ask you this. Let's do this differently. Let's say that our car is driving, okay, here we go. Here is our velocity function. Okay, yeah, I like this. So we're gonna do another one. Keep trying.
There's some specific thing you want us to do, but it doesn't seem like you need to do it that way.
Oh, you do. V of t equals t squared. That's our velocity function. So then I want to know what's v bar on the interval from 1 to 4. Let's say average velocity.
Oh, I see what I'm saying.
Oh, okay. Yeah,
Okay,
yeah. Right?
so it has,
So maybe we need a picture, right? We don't really need a picture, but I think it's helpful to have a picture. So if this is our velocity time graph, then the function just looks like this, right? And we're going from 1 out to 4, right? So we want the average velocity, okay? What's the area under a velocity time graph equal to? Do you remember? I just think about it in terms of what the physical meaning is here, right? If we're doing, this is velocity, this is time, an area would be the product of those two dimensions. So it's displacement, isn't it, right? So the area under the curve is displacement, right? So from 1 to 4, that's the displacement, right? So how would I find average velocity if I know displacement and I know time?
if you find the area underneath it, then you can figure out what half the area is, figure out where that slides over.
Well, I don't even need to know what half the area is. I just need to know, just think about this in terms of, if I know that I travel the displacement of 10 meters in 2 seconds, what's my average velocity? 5 meters per second, right? Okay, does that mean that I traveled 5 meters per second the whole time? No, it doesn't necessarily. I might have started at rest and accelerated real fast, right? But still, if I covered 10 meters in 2 seconds, my average, is that what I said it was for you? Average velocity is 5 meters per second, right? Okay, I could have traveled at constant speed for 2 seconds at 5 meters per second, but I didn't have to, right? Okay, so did I travel at constant speed here? No, I didn't. But I still covered that much displacement, the blue area, in 3 seconds, right? Agreed? Now I could reconfigure this with my 2-dimensional calculus grinder. It's a DeWalt. And if I grind this thing down, oops, if I grind this thing down from the top, so I bring in my grinder and I grind this thing down from the top until the rubble fills in the little depression there, and it's all rectangular. It's gonna be about, I don't know, about there maybe. I could reconfigure it so it looked like that if I wanted to. Same area, right? Agreed? Then this would be my average velocity, wouldn't it?
Yeah.
Right? Everybody agree? Okay, so really, all I've got to do is just take the total area divided by the width, and that's going to give me my average value for the function, right? Agree? Okay? So all I'd have to do, how do I find the total area there? What's the blue area? Calculus, right here. What's it going to be?
The left and right side.
Okay, so it's, okay, but we don't have to do all that. Let's
No.
forget that stuff. We can just
doing
use,
the Riemann.
yeah, we'll just use the fundamental theorem of calculus, or we'll just use a definite integral. So we can just take the area, the blue area, which we'll call a sub b. That's just going to be the integral of,
For
okay, 1 to 4 are my limits of what?
t squared dt.
Yeah, right? Because think what this means. This means if we parse this into kind of like a graphical interpretation of this, the integrand, that's the curve, and we're looking for the area under that curve, right?
Yeah.
Agreed? So this just says, the area under t squared from 1 to 4. Isn't that what that picture represents?
Yeah.
Right? So what's the antiderivative of t squared?
T cubed to the third over third.
So we're just going to evaluate that from 1 to 4, right? So doesn't that just give us, so that gives us 4 cubed over 3 minus 1 cubed over 3. Or if I want to, I can pull the 1/3 out front, right? Either way, I'm just going to get 64 thirds minus 1/3 is 63 thirds, right? Which is what? That's something, 21? Yeah, right. What is that? Am I doing something totally crazy here?
No, it's
No, it's 21.
It's always 21.
Yeah. Yeah.
Always 21.
Always 21? Was that your answer that one time?
Yeah. That was that one that I just guessed on.
Yeah.
Like, yeah, it's 21.
Yeah. So it's, yeah, it's always, pretty much always 21.
Calculus.
That's, what'd you learn this year in calculus? 21. Yeah.
It's a
Okay.
good quote. Everything's
That kid's always been right. Plus 10 doesn't.
So that's the average velocity, right? So then let's go back here. How do I do this? What's the average value of f of x equals sine x on 0 to pi?
Antiderivative.
So, yeah.
It's the integral, definite integral
Derivative.
of f of x, right? In fact, we could, if we want to make this more general, we could just say that the f of c equals the integral of f of x dx from a to b over b minus a, if a and b are the limits of integration, right, the left and right limits of my area, the function is f, and c we're going to define as the values of x where the function has its average, right? We just interpret this. F of c we just interpret as f bar. That's the average value, right? Okay, so then what do we get here? Well, no big deal, right? We just say f of c equals what? Integral of 0 to pi of
Sine x dx.
divided by pi. Pi minus 0, which is just pi, right? So what's that give us? What's the antiderivative of sine x?
Negative cosine.
Negative cosine from 0 to pi divided by pi. And so what's cosine of pi is? Minus cosine of 0. 1. So that's 2 over pi. Everybody agree?
So really, it's pi 8, that's half, because pi, the average of the. Well, 0 plus pi divided by 2, so the average of the integral. So 0 pi, that's pi over 2, and then it's reciprocal.
Okay, don't think that's generally true. The answer is not 21 here.
If it's not that,
So-
it's 21. Just
Okay, so what if I change this though? I could make this harder. I could ask you the question, I could also ask you the question, what if I want to find all the value or values of C where the function has its average value? How could I do that? Right, see what I'm saying here? So that'd be like saying if we went back to this picture right here. This is C in my picture. Right there, that's the value of X, where the function had its own average value, right? If I were going to, for example, let's take the kinematics example we talked about. If I'm going to accelerate from 0 and somehow cover 10 meters in 2 seconds while accelerating uniformly, my average velocity is 5 meters per second. So at some point, I'm going to go from 0 to some high speed. At some point in between, I'm going to have a speed of 5 meters per second, right? That's C. Whatever that time is, that's what we define as C. Okay, make sense? All right, so for this problem then, so I want to know C equals what? How would I find out?
So is that trying to figure out where the function equals?
Exactly, that's it. So what am I doing? What's the equation I'm solving? This isn't really calculus.
Sine x equals 2 pi.
Sine x equals 2 pi. Solve that. 2 over pi, right? So what's the answer?
Or sine of 2 pi.
Arc sine of 2 over pi, right? That's it. Okay, now, if we're going from, now here's where we could use the unit circle a little bit. Arc sine of 2 over pi. 2 over pi is that's less than, what is that? That's like a little more than 1/2, right? Everybody agree? So here's a good little trig review. Where's the primary domain of a sine function? What's the primary domain of a sine function?
What is a primary domain?
Yeah.
Come on.
The
You guys
first
talk.
domain.
No, the primary domain of sine function from pre-calc would be what? So a capital S sine function is defined where?
These are definitely not
What?
terms we use when we're learning trig.
No idea. Primary domain?
Anybody? Because that is not what we did not
No
learn
idea what
any
that means.
terms like that.
Okay, well, we probably need to talk about this at some point.
I think we should.
I'm not gonna do it right now, but this is, okay, so here's how you think about the primary domain of a sine function. Sine function exists, the domain's infinite, right? But what is the most convenient domain that's gonna give us all possible outputs of a sine function? Domain, you always take quadrant 1, but what's the other quadrant? Sine is a vertical function. 4 and 4, that's it. That's the primary domain of sine.
Oh, that's.
Is
Okay.
remember doing this a little bit?
Yeah.
Well, not with those terms, but yeah.
Okay, but those are the terms. It's
Well,
the
yeah,
primary
but-
domain, or you might have called it principal domain.
Maybe.
Okay, but this is where a capital S sine function is defined. So if we write f of x equals sine x, the natural domain is all reals, right? But if we write f of x equals a capital S sine x, the domain is negative pi halves to positive pi halves. Okay, that's where it's defined, right? And so, when we take an inverse sine, we're only going to get back, there are an infinite number of answers to this question, right? Where does sine x have the value of 2 over pi? Well, look on the unit circle. On the unit circle, it's going to have that value, that's about right there. So I'm going to hit that value an infinite number of times when I go around, right? Does that make sense? But within the primary domain, it's only going to give me back that one angle. You agree? right? Because in quadrants 1 and 4, that's only gonna happen once. If we start at negative 2 pi and go up to or negative pi halves and go up to pi halves, try it on your calculator. Yeah, or I'll just pull up mine. If I say,
It's easy to just.
so if I go, I want to turn my calculator into radian, put it in radians mode. And I'm going to do inverse sine of 2 divided by pi.
Second, carrot,
Oh,
over. Oh,
H.
right there. There we go. Okay. And it gives me about 0.69 radians. So if I take that, that's how many pi? If I divide that by pi, see what I'm saying? Like if I divide that by pi and I got back the answer 1/4, right? Then that would be 45 degrees, for example, right? You see what I'm saying? Like, let me show you real quick. Like if I do the inverse sine, I'll just want to show you what I'm doing here. This is kind of handy. Inverse sine of pi fourths, let's say. Or inverse sine of square root of 2 over 2.
It's gonna give us, space.
Okay, thank you.
Okay, so that's going to be, gives us that, right? What the heck is that? Well, if I divide that by pi, oh, that makes sense. It's 1/4 pi. See what I just did? Right? That's an easier way to think of it in terms of a unit circle, right? So if we go back up here and grab this guy, oops, one more up, that guy, and we divide that by pi. So it's a little less than 1/4 pi, right? So where is that on the unit circle? Well, about there, right? But it only gives us back 1, right? It only gives us back 1 because it gives us back the one that's in the principal domain or the primary domain of sine, right? It's giving us back the capital S inverse sine answer. But where else would that occur on the unit circle? Where else?
181.
Where?
201. 201 degrees.
No, where would because sine is a y value,
Well, yeah,
right?
quadrant.
So it's going to be, I could reflect this into
Second quadrant.
second quadrant, right? This one's also going to get, those 2 points have the same sine values, don't they?
Yeah.
Right? So technically, I've really got 2 values here. I've got inverse sine of 2 over pi, and then I've got pi minus the inverse sine of 2 over pi. Right? Would be in my domain.
Well, isn't it more so just that it's not on the 0 to pi because it's less than? Wait, no, never mind.
Right, because we're looking for all the values between 0 and pi. See what I'm getting at?
No.
So when I in my calculator, when I get this value, I forgive me for digressing here, but I want you guys to see this because this is something that, like oh shoot, I didn't want to do that. Can I go back up and right there? So there's the inverse sine, right? That's one value. Okay, so that's one answer. The other answer would be pi minus that value, right? You see that?
Yeah.
Because I'd also have this angle, let's make this a green angle. Right, I've also got that angle right there, right? Because isn't the output of an inverse sine function is an angle, right? Right, we're reversing, the input of a trig function is an angle, output of an inverse is an angle. So we're going to get back this angle, but it should also be that angle. Well, isn't that just theta right there? Right, so 180 minus theta, or pi minus theta. See what I'm saying? Okay. Let's look at this a different way. This is kind of cool. Let's go on to Desmos. How about? Oh man, was I not taping this? Oh my gosh.
Oh, no. Quick, turn on the
This is-
recorder and then just quick review.
This is just terrible. I mean, this was gold. This thing was just coming. Every once in a while, things just come together, and it's like, oh my gosh, this is
Time to
just
go home. Get that.
work of instructional art.
Instructional art.
So we just want to know, when does sine x equal 2 over pi, right?
Yeah.
So that's what we're doing. There's sine x. Let's intersect that with 2 divided by pi. And,
Equals X, Y.
oh, I have to do y equals, don't I?
Yeah.
There we go. So let's find those intersections. Hey, what do you know? How about that? That was one of our answers, wasn't it? Right? That's what we got back for the inverse sine was 0.69 something, right? And then what's the other one? 2.451.
Pi.
Yeah, what did we get?
Or minus pi.
So I never hit enter, but what do you know? How about that, right? See what I'm saying? Okay. It's going to intersect it obviously if I extend the sine function out, there's going to be an infinite number of intersections, right? But between 0 and pi, those are my answers, right? Make sense? Okay. Isn't that cool? It all comes together. And the pupil becomes the teacher. That's the next stop. I don't know where I got that from. That seems like kind of a Star Wars thing. I don't know.
Yeah, it was, with Anakin and whatnot.
Okay. See, I knew answers are 21 in Star Wars.
No,
Okay. Got another one for you. That's not enough. Got another one for you.
I don't know if you know the
No, that's not me. I've never. That's not I.
I thought you were started.
Who posted it?
Probably
Started back, that's where I found it.
My goodness. Okay. I would like you to find.
And strike 2. Go home. Start your buses.
I was about to give you good old Scott slide.
It's fine.
I'm gonna let his razor face get destroyed.
Okay, let's do. Okay, I gotta make one up here real quick. Let's say we want the.
Be a good roll. Pillows. You know Jared, obviously, right? Yeah. Did you hear about the time he slapped in the face with a piece of pizza? Oh,
Yeah.
Jared, he was on like Dylan and George's bed in the hotel, and he was like, "Jared, move, give me my bed back." And he's like, "No," and he's like, "What are you gonna do about it?" And he's like, "We were eating pizza," and he's like, "I'll slap you right across the face with this." And he's like, "No, you won't." And then you just hear it's like the perfect slap. You just hear it, just it's so solid, and then you just hear it, and then you just watch Jared do this, trying to get it so late, and he did it 4 times. We had it on video for a while, but then Sam apparently lost it on his phone.
We were talking about tortillas.
Okay, how about that?
Okay.
I want the total or gross area under the curve. Now, what do you think I mean by that? If I said just area or net area, that's pretty easy, right? If I want just the area, let's do that first. Let's just find the regular area. What if we say find?
Wait, so the gross one, that'd just be the one where you have to find both and find the average?
No.
No, I guess. That's the last thing I remember doing in this class. So I was in keep going.
We're at 0 to 3?
Yeah.
Well, that's easy. I mean, that's just first fundamental theorem of calculus. So how do I represent that area with an integral?
Integral 3 to 0.
0 to 3.
X squared minus 3x plus 2 dx.
So what's that give us then?
X cubed over 3 minus
What happens at 0?
0.
Okay, so I just have to evaluate it at 3.
Yeah.
So our answer is just 27 over 3 is 9 minus 27 halves plus 6, which is what? 18, so negative 9 halves plus 12, so 3 halves,
Yeah.
okay?
That's what I
Not very big, okay? Why? Well, let's calculate the area here. I think I can do this using Desmos also. I haven't done as much with Desmos as I would like to have. So we got x squared minus 3x plus 2. Okay, good. And let's do some stuff with that. I think there's some things I can do with that. I think, see, here's where I don't really know how to do some stuff with Desmos that I'd like to be able to know how to do.
Do the area.
Yeah, like if I go
I think you're using a different
functions.
website. Sorry.
Yeah, so I'll tell you what, for now I'm just going to use the calculator. Calculator's fine. So let's go y equals, same thing. So we got x squared minus 3x plus 2. And let's set our window up to go from 0 to 3.5. I'll go negative 0.5 actually.
I know, I texted her.
Okay, and let's just go zoom fit. Okay, agreed? So now watch this. This is pretty cool. So let's go into second calc, and oh, what do you know? Number 7. Look at that. Looks like an integral. So if I want to take the area from 0 to 3,
Oh my.
That's a legend.
look at that. And we get 1.5.
5.5.
Okay? That's in the bottom, it says 0, 3. That's our interval, right? Pretty cool. Okay? So it's telling us what the area under the curve is. Okay, but what's going on there?
It's because we have some underneath.
What's true about that underneath area? What's that doing?
It's negative.
It's negative. So what if I wanted to find, instead now, what if I wanted to find the area represented, if I had to like cut that out from paper? What's the area of the paper, which we might call the gross area? If we treat all the area as being positive, how could I find that?
Figure out what 0 to 1 is.
Okay. So you're noticing something here. Where are the zeros of that function?
At 1 and 2.
At 1 and 2, which we could find by setting it equal to 0 and solving. It's a simple quadratic, right? So then we know that if those are the zeros, all I'd really have to do, if I even want to just be generic, let's just make these the zeros of some function. How could I find the gross or total area if I know where the zeros of a function are?
You can figure out where you need to add and subtract.
Okay, but if I want to make it all positive,
Absolute value.
I could take the absolute value, right? I could just take the absolute value of the area on the intervals between the zeros, right? You see what I'm saying? Everybody get that? So we could do this, right? We could say, okay, if we want to do, if I want to do the gross area, well, we know that the zeros, if I set this thing equal to 0 and solve, oh my gosh. Holy smokes.
Hashtag thick.
Yeah, right there. To the left.
Oh,
Right there, there we go. Okay, that's a little
You
better.
could have just pressed the button.
Can you?
Yeah, well, it lit up after you were
Yeah, so-
underneath it, so apparently.
Oh, I learn something new every day. That's good. I've been battling that for years. That's all I had to do.
Yeah, you try it.
So the zeros are at 1 and 2, right? So all we'd have to do to get the gross area would just be to take the integral of f of x
Like, this is standing in the middle of the
From what
you
to-
don't need that.
from, well, from 0 to 1.
Well, but we only need.
Right, but let's just say we haven't graphed it, right?
Okay.
So we've got that plus the absolute value of the integral of f of x from 1 to 2 plus the absolute value of the integral of f of x
2 to 3.
from 2 to 3. And the integral is the same every time. I already did the work, right? The work is, oh, where is it? It's right there, right? So I don't want to figure out what that is in terms of x, but we could just take this thing, because we already did all our work. Oops. Come on.
She's pretty good. Why are you back this?
Oh, man, talk about harnessing the power of technology.
I don't know if I'd go that far.
Yeah,
Struggle with the
come
slider
on.
for a few minutes,
Come
but
on.
Few years.
a few years apparently.
Yeah, that's true. Fairly inept, it's true. So then this one just goes from 0 to 1,
It's really nasty.
and we'll take the absolute value of that, plus the absolute value of this guy from 1 to 2, plus the absolute value of this guy from
2 to 3.
2 to 3, right? So that's our answer. Right? We good? Okay.
like it. I like it a lot.
Would the word under be misleading in this fact?
What's that?
Will the word under be misleading?
Yes, I mean, it is kind of, but when you talk about, so in calculus, you're right, when we say the area under a curve, it's always implied to mean the area between the curve and the x-axis, yeah. Okay, so one more for you here to think about. How much time we got?
1 minute.
He's ready to go.
Should write a strongly worded letter to Greeno.